Distributed Database System presented by Rupali Banerjee. So today our topic is Primary Copy Protocol for Concurrency Control of Distributed Transactions. So what is Primary Copy Protocol? Assume that we have the data item queue and that data item is replicated in several sites. Now we have to choose one of the replica of data item queue as the primary copy. That is, many replicas are there and we have to choose only one replica as the primary copy. The site which stores the primary copy is designated as the primary site, and that copy is stored in a particular site. That site is called primary site. Now, any lock request generated for data item queue at any site must be routed to the primary site. So, from any site, if any lock request generated for data item queue, then that lock request must be routed to the primary site, and primary site lock manager is responsible for handling lock request. Though there are other sites with the same data item queue and local lock managers, but all requests to lock or unlock queue are handled by the lock manager at primary site. We can choose different sites as lock manager sites for different data items. If the lock can be granted, lock manager sends a message to the site from which request was initiated. Otherwise, the request is delayed until it can be granted. We will take one example, then this topic will be more clear for you. See, how does primary copy protocol work? This is distributed system. This is site 1, site 2, site 3, site 4, site 5 and site 6. They are connected with intercommunication network. QRS are data items and LMS stands for lock manager site or primary site. So, S1 is LMS for data item S, S3 is LMS for data item Q, and say S6 is LMS for data item R. Q, R and S are different data items that are replicated. See, Q item is here, Q item is also here, Q item is also here, R is here, R is here. So, Q, R and S are different data items that are replicated. Q is replicated inside S1, S2, S3 and S5. But site S3 is designated as the primary site for Q, that is LMS for Q. LMS means lock manager site for Q. Though replication of Q are in S1, S2, S5, but this site is chosen as the primary site for Q. R is replicated in site S1, S2, S3 and S4. Site S6 is designated as primary site for R, that is LMS for R. S is replicated at sites S1, S2, S4 and S5. Site S1 is designated as the primary site for S, that is LMS for S. The concurrency control mechanism works this way. Step 1. Transaction T1 initiated at the site S5 and request lock on data item Q. See, data item Q is available at site S5. Even though the data item is available locally at site S5, the lock manager of S5 cannot grant the lock. Why? The reason is, in our example, site S3 is designated as the primary site for Q. Hence, the request must be routed through communication network to the site S3 by the transaction manager of S5. Step 2. S5 request S3 for lock on Q. For this reason, S5 sends a lock request message to S3. Step 3. If the lock on Q can be granted, then S3 grants the lock and sends a message to S5. On receiving log grant, S5 executes the transaction T1. It is executed on the data item queue available locally. If no local copy, then S3 has to execute the transaction in other sites where queue is available. Step 4. On successful completion of transaction, S5 sends unlock message to the primary site S3. Now, one thing you have to remember, if the transaction T1 writes the data item queue, then the changes must be forwarded to all the sites where queue is replicated. If the transaction read the data item queue, then there is no problem. Advantages. Handling of concurrency control on replicated data is like unreplicated data. It is very simple to implement. Only 3 messages are required to handle lock and unlock. First one is lock request, second one is granted, and third one is unlock message for both read and write. Disadvantages. Possible single point of failure means if the primary site of a data item say queue fails, then even though the other sites with the same copy of queue available, but the data item queue is inaccessible because primary site fails. Our next topic is majority based protocol. Majority protocol is one of the methods in distributed lock management for concurrency control. In this protocol, local lock manager is responsible for locking and unlocking the data. Majority protocol has the same behavior with both shared lock and exclusive locks. Majority based protocol. In this protocol, majority of copies must be locked in case of both read and write request for a data item. Assume that we have the data item queue which is replicated in several sites and the majority based protocol works in this way. A transaction which needs to lock data item queue has to request the lock data item queue in half plus 1 sites in which queue is replicated. That is, majority of the sites in which queue is replicated. Say queue is replicated in 10 sites. Then 10 divided by 2, that is 5 plus 1 site, the request will be sent. That is, if queue is replicated at n sites, then a lock request message must be sent to more than half of the n sites in which queue is stored. Here, the lock manager of all the sites in which queue is replicated are responsible for handling lock and unlock requests locally individually. That is, local lock manager at each site administers lock and unlock request for data items stored at that particular site. Irrespective of the lock types, that is, it may be read lock, write lock, shared lock, or exclusive lock, we need to lock half plus 1 sites. The transaction does not operate on queue until it has obtained a lock on a majority of the replicas of queue. When writing the data item, transaction performs writes on all replicas. Take one example, then this thing will be more clear for you. Example. Let us assume that queue is replicated in 6 sites. These are 6 sites. S1, S2, S3, S4, S5 and S6, and it is connected by a communication network. Then we need to lock queue in 4 sites. Why? Because half means half of 6, that is 3. 3 plus 1 means 4. So we need to lock queue in 4 sites. When transaction T1 sends the lock request message to those 4 sites, the lock managers of those sites have to grant the lock based on the usual lock procedure. So at least 4 sites should grant the lock. Otherwise, it will not work. Now see how does majority based protocol works. See the implementation. In this figure, Q, R and S are different data items. Q is replicated in sites S1, S2, S3 and S6. R is replicated in sites S1, S2, S3, S4 and S is replicated in sites S1, S2, S4, S5 and S6. So Q, R, S are replicated data items and different sites are from S1 to S6. Let us assume that transaction T1 needs data item Q to be locked either for read or write mode. So step 1 is transaction T1 initiated at site S5 and request lock on data item Q. Q is available in S1, S2, S3 and S6. According to the protocol, T1 has to lock Q in half plus 1 sites. That is, in our example, we need to lock any 3 out of 4 sites. Assume that we have chosen sites S1, S2 and S3. Step 2 is S5 request S1, S2 and S3 for lock on Q. The lock request is represented in purple color. Step 3. If the lock on Q can be granted, S1, S2 and S3 grant lock and send a message to S5. On receiving lock grant, S5 executes the transaction T1. It is executed on the data item Q which is taken from any one of the locked sites. The lock grant is here represented by the green color. Step 4. On successful completion of transaction, S5 sends unlock message to all the sites S1, S2 and S3. The unlock message is represented by blue color. Remember, if the transaction T1 writes the data item Q, then the changes must be forwarded to all sites where Q is replicated. But if the transaction reads the data item Q, then there is no problem. Advantages. Here, replicated data handled in decentralized manner, so no single point of failure occurred. Disadvantages. Implementation is complex. We need to send n by 2 plus 1 lock request messages, n by 2 plus 1 lock grant messages, and n by 2 plus 1 unlock messages, irrespective of lock requested, that is, read or write. Here, both read and write involve same level of complexity. Here, deadlock may occur. To handle this deadlock, we may need to impose an order in which the locks can be requested. Now some points to note. Transaction can execute only after successful acquisition of locks on majority of the replicas. Needs to send more messages. 2 into n by 2 plus 1 lock messages and n by 2 plus 1 unlock messages when compared to primary copy protocol, that is, in case of primary copy protocol, it is 2n plus 1 messages. Local lock managers are responsible for granting or denying the locks on requested items. Not suitable for applications where read operation is frequent. When writing the data item, a transaction performs writes on all replicas. When handling with unreplicated data, both requests can be handled by requesting the site at which the data items available. Now see types of questions for your university exam. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.